This question came for 2 marks in AC GATE 2019. The question is, in the circuit shown, Vs is a 10 volt square wave of period t is equal to 4 milliseconds with R is equal to 500 ohm and C is equal to 10 microfarad. So here the time period is given, which is 4 millisecond, and R is given, which is 500 ohm, and C is given, which is 10 microfarad. The capacitor is initially uncharged at t is equal to 0 and the diode is assumed to be ideal. The voltage across the capacitor at 3 milliseconds is equal to dash volts, and of course it is given rounded off to 1 decimal place. Okay, so there was what is the voltage across the capacitor at 3 milliseconds. So if you look at it, the input voltage waveform, the period is 4 milliseconds, which means half of it is going to be 2 milliseconds, and 3 milliseconds would be right here, which will be 3t by 4. Now we need to find what is the voltage across the capacitor at 3 milliseconds. So let's investigate this. So the initial information given is at t equal to 0, the capacitor has no charge, which means the voltage across the capacitor to start with is 0. Now let's see when t is in between 0 and t by 2. Now right at t is equal to 0, a plus 10 volts is applied. So when plus 10 volts is applied here and the voltage across the capacitor is 0, the diode will be forward biased, as the P side is at higher potential than the N side. When diode is forward biased, the circuit would become like this, where it is a simple RC circuit. Now current would be flowing and the capacitor would get charged. We know how this capacitor gets charged. The equation, voltage across capacitor, is given by Vm times 1 minus e power minus t over Rc. This Vm is the input voltage that is applied, which is 10 volts, times 1 minus e power minus t over Rc. Now our intention is to find the voltage at 3 milliseconds, but this applied voltage of plus 10 volts is valid till t by 2, which means till 2 milliseconds. We need to find what is the voltage at 2 milliseconds first, and then we will go to 3 milliseconds. We will take t over Rc. R is 500 ohms and C is 10 microfarad. So Rc is 5 milliseconds. Now we need to find the voltage across the capacitor at 2 milliseconds. This will be 10 times 1 minus e power minus 2 milliseconds or 5 milliseconds. This value is 3.3 volts. The voltage across the capacitor would increase and it becomes 3.3 volts when t is equal to 2 milliseconds. Now let's see what happens. Let's make a note here. This value is 3.3 volts. Now let's see what happens when minus 10 volts is applied to this circuit. So when minus 10 is applied to this circuit, minus plus here 10 volts, and the voltage across the capacitor at this point is 3.3 volts, which means the diode P side is negative and N side is positive, which means the diode will be open circuit. Hence we're going to keep this open circuit and see what happens. In this case, there is no conducting or discharging path, hence the voltage across the capacitor would remain 3.3 volts for the next half cycle, as the diode is open circuit. Hence the voltage across the capacitor would remain 3.3 volts throughout this half cycle, which means obviously at 3 milliseconds as well, the voltage across the capacitor will be 3.3 volts. Hence the answer is 3.3.